Doozer Shop. Welcome to Doozer Shop. We always have a great time at Doozer Shop. Got some footage here this week for all you Gorton freaks. Got my Gorton 9J. Was going to do some milling on it and the table started getting tight. And I needed to take it apart and investigate. So let me take you over handheld. We're going to look at a Gorton 9J milling machine taken apart where the table mechanism. Let me show you. All right, that's a Gorton 9J, and I got it all taken apart. I got the screw out. Let me back up. I'll show you. On the parts washer, I got the lead screw, and got it all taken apart. It's got a. I want to show you guys. It's got a keyway in the screw because it's got power feed and had a burr. Well, kind of, sort of. Got some bluing on there. And let me take you over. I'll show you what I got. All right, there's the Gorton. I got the table slid over. Kind of walk you through this. So you can take the lead screw off of a milling machine, like a Bridgeport or a Gorton, and what you can do is you can disconnect it from the bronze nut and slide the table off. Not completely off, mind you. Let me show you. Okay, see, there's the saddle, and from the end of the table to the saddle, I got about, 9-10 inches there. So, it's not overstressing anything, the dovetails, but I wouldn't go any less than that because, boy, it's hanging off in free space there. But as long as you leave at least, 9-10 inches, you're good. But the reason I had to do that is I had to access the internal mechanism of the screw. And, well, let me show you. That's the end there that these three screws bolt on, and that's the end piece. And it's got Timken ball bearings, tapered roller bearings on the ends of the table. And that, boy, we're almost touching the Van Norman. That bolt's over there on the end. But what's going on here, bring you guys over as steady as I can. We've got some power feed mechanism, and this thing is the tertiary crank. Not only there's cranks on the end of the lead screw, but there's this third one, and you can kind of see how it works. There's some bevel gears, miter gears, and inside here, this bushing assembly, there's a feather key that goes in the slot of the lead screw. And when you turn this, it turns in the keyway. The feather turns in the keyway of the lead screw, and it's like another handle. So that was kind of where the problem was. But this is the actual nut. This is the bronze nut that secures the table to the saddle. So the lead screw for the x-axis runs in this nut. It's not a split nut, and I don't ever advise splitting a nut to take out backlash because you reduce the bearing area. You cut it in half. But this thing is in fine shape. So this is, like I say, this is the tertiary crank, and there's a feather key in there. There's the primary, well, the only bronze nut. Now, This here, this is kind of cool. There's nothing wrong with this. This is the power feed, and you can see this is the power feed for the table, and it moves that dog. When you move this trip lever, there's a yoke, and it's not going to go because it has to be spinning to get everything lined up. But this goes to the left or to the right. And these bevel gears spin. There's one, I'll kind of show you. The power comes in here. This is the input gear, and it goes to a shaft outside that drives it from a gear case. So power goes from this gear to that gear, and you can take power off this bevel gear. Well, see, there's clutch dogs. So this bevel gear, really the only function it is, there's another bevel gear underneath all this, and then it goes to this gear, and there's face dogs on this. So that's your power feed, left and right. Let me kind of back up. Yeah. But the problem was, you kind of go around here, I got tools on the floor, that the bore inside this bushing gear, whatever, was so tight, I thought it was the feather key in here. So in the keyway, in the lead screw, but it wasn't. It was this bore. It's just tight on the OD, the major diameter. Let me kind of. All right. See, there's a set screw there, and a set screw there. What that is, this is an adjusting nut for the free play in this bushing. That's all it is. But I noticed when you tighten these up, it would, egg shaping out around that bore, and it would get, there was a tight spot in the travel, and it would get even tighter with this. So what I'm going to do is I'm going to take these Allen screws out and get this off. I might have to, there's a set screw at the bottom that allows you to pull this whole shaft out. That could, it would slack up the teeth here, withdraw that back, take the teeth out of mesh, and I could pull this out because it's in dowel pins. So I can get this out. I'm going to take the sleeve out of the bushing, and I'm going to bore 5 thou out of here. And the feather key is just up in the gear area. This whole area in the back is just a smooth bore. So I'm going to open it up 5 or 10 thou. I might do a 10 thou right under these set screws and 5 thou the rest of the way in the lathe. Bore it out, chuck it up, bore it out, put in the forejaw, indicate it, and create some clearance there. Now this does not have to be tight. It has to be, this bronze nut has to be true and good and proper. But this is just clearance. It's got to be tight around the feather key, but it's binding over here. And I think there's a spot on the lead screw over there that the major diameter, the outside diameter, and just this one little 1-inch section is just like a thou bigger. I don't know why, but that I blued it up, and that's what it was, indicating the bluing was coming off just a little bit. But that's the problem, and I used spray-on blue Dykem dye, and that's kind of how I traced all this down. But on a Gorton, okay, let me show you something you Gorton guys don't know. This is my nice new leathers. This flip top oiler gets oiler, and that oiler are for the Y ways, the in and out ways. And I thought these oilers were for the ways, but I don't think they are. I think these little flip cap oilers are for, like, this one goes down and feeds that bearing. This one is plugged, it goes down and feeds that bearing. And that one feeds you know, that gear in the middle, and that one feeds that bearing, and such, you know, so forth. What feeds the table in these ways is that oiler on the table. It's a little bit bigger Gitz cup oiler. So that oiler feeds the left and the right sides, and there's there's these little passages on the underside of the table where that Gitz cup distributes it on both sides. So that's that. This whole area here was greasy like you wouldn't believe. There was so much grease in here. Let me zoom you in. I'm gonna give you. This thing was black and greasy and nasty, and there's chips of aluminum that had got in there over the years. Man, this thing was nasty. I cleaned the ever-living heck out of it. Yes, this thing was so greasy. One thing I wanted to show you guys also is this gib. Let me back up. I'm going to trip on my vacuum cleaner hose. Ugh. Let me get you. All right. All right. So this is the gib. If you can see, it's tapered along the length as it goes back, it tapers. So the dovetail, this is the flats. The dovetail goes in there in the table. You can kind of see it. The dovetail goes in there, and the dovetail goes there, up against the gib. Now the reason it's tapered over the length is you can tighten this gib screw. It's not in there, I got it. All right. That's, just set it there. That's the gib screw. Yeah, go back down. And that screws into there. And the corner of it, the corner of that screw, you can see it, it pushes on the gib. So you tighten this one to wedge the gib in, and it pushes the gib out. And you tighten, there's one of these on the back side, way down over there. You tighten it, and it loosens the gib by pushing it towards the camera. I found the problem where these, you can see how nice and ground shiny it is. These slot-headed screw gib adjuster screws were heat treated and warped. These heads were not running concentric with the threads, so both of them were doing that. So what it was doing is when you put it tightening in there, it would be pushing sideways on the gib. When you turned it, you could feel it going womp, womp, and you could see, when I was watching, you could see that gap get bigger and smaller ever so slightly. So on both of these, I put it in my 5C collet spin dexer, and I used the surface grinder, and I spun them down, so, you know, like cylindrically ground them. So now these are concentric within, you know, less than a thou, done on the grinder. So they're not forcing this gib out at all. So that was kind of a factory oversight. Now, you can't see this on camera, but these gibs, I had this gib out. I put it back in because the table has to be, the gib has to be in for the table not to fall off. These are planed. There is linear planer marks all on that gib. And this thing is in fine shape. This machine is a honey. I mean, this thing was hardly used. I think it's a 1942 war baby. But this thing is in really good shape. The thing has always been kept oiled. I think it was in a shop where they had a Bridgeport and just nobody used it. But all the, like I said, you can't see with this goofy camera, but all the planer marks are on this gib, and you know, there's flaking, scraping marks under here, and you might be able to see flaking, scraping marks all over the top of this thing. This thing is in really good shape. And let me see my indicator. I got the indicator in the spindle. That spindle, I think, is number 10 or 11 Brown and Sharp taper. I forget which. But there's an adapter I got in there, sleeving it down to an R8 collets. Just regular Bridgeport collets are up in that spindle. So, and it runs dead true. I mean, it's got tenths run out. The thing is really really nice. You see the Van Norman 22 LU in the background there that I'm shooting here with my camera. But this is a really nice mill, and I just wanted to show you guys a little bit about what we had going on here. So next time, this is Doozer Shop.